Hello everyone, welcome to EnggClasses YouTube channel for a video lecture series in digital signal processing. In this video lecture, we shall consider the concept of design steps followed in the design of linear phase FIR filter. So basically, if I consider the design procedure, there are three steps. If I consider the first step, step number one, we begin with the desired frequency response specification, HD of omega, and determine the corresponding unit sample response HD of n by finding the inverse DTFT of HD of omega. Is that okay? First, we need to find the inverse DTFT. How do I find that? HD of n is equal to 1 divided by 2 pi integration of minus pi to plus pi HD of omega e to the power j omega n d omega. So this is the very first step. Moving on further, if I consider the step number 2, in the step number 2, we need to find the impulse response h of n and the filter coefficients hd of n. So how do I do this? H of n is equal to hd of n into wn. That means I need to multiply hd of omega with the corresponding window. What is that window? That window could be of 4 or 5 different types depending on what it is mentioned in the numerical. W of n is a window and it can be a rectangular window if it is mentioned. In the numerical they mention design the filter using rectangular window. That in that case I need to multiply hd of omega with rectangular window. And it could also be Bartlett window, Hamming window, Hanning window and Blackman window. Corresponding to these I need to multiply hd of omega with w of n. That is step number 2. Moving on further, what could be the step number 3? Depending on whether n or m is odd or even, find the frequency response. This is the last step. We need to find the frequency response that depends on whether n or m is odd or even. What if n is odd? Then we have the formula for this. We need to make use of this formula and find the frequency response. Is this fine? And what if n is even? If n is even, again we also have another formula. Making use of this, we need to find the frequency response. And again, the important point here is we need to remember these two formulae to find the frequency response. Thank you so much for watching.